Hello students, in this video we're going to go over some homework questions from section 4.1 on probability distributions. So this is question 1 in the homework for section 4.1, and the question simply asks, what is a random variable? Okay. So if you look in the book, it gives you the definition of a random variable. Okay, so I encourage you to read the definition of a random variable and select the appropriate answer choice. So select the answer choice that most closely matches the definition of this word given in the book. So I'm going to go ahead and go to the next question. Okay, and question 2 says, decide whether the graph represents a discrete random variable or a continuous random variable. Okay, so it's important to understand what these terms mean. So, right, what's a discrete random variable and what's a continuous random variable? So let's review these definitions in the book. So in the middle of page 190. Okay, it gives the definitions of discrete and continuous random variables. So let's scroll back down to view the definitions. Okay, so a random variable is discrete when it has a finite or countable number of possible outcomes that can be listed. Okay, and then a random variable is continuous when it has an uncountable number of possible outcomes represented by an interval of on a number. Okay, so for a discrete random variable, the keyword here is that the outcomes are countable or can be listed. Okay, so likewise for a continuous random variable, the possible outcomes are represented by an interval on the number line. So that those will help you remember the difference between the two types of variables. Okay, another way to remember those two definitions is that discrete random variables, okay, are things we count. Okay, so that's what makes a random variable discrete. So if it's something that we count, like for example the number of kids a person has, or the number of pets a person has, right, those are things we count, right, that would be a discrete random variable. Okay, likewise, continuous random variable, okay, are things we measure. Okay. So an example of things that are measured, right, are a person's height, a person's weight, or even a person's age. Okay, so a person's age is a measurement of time. Okay, so age would be considered continuous. Okay, so based on the definitions in the book, and then the alternative definitions that I just shared with you, right, you would answer those questions accordingly. Okay, so for example, the home attendance for football games at a university. Okay, so decide whether that's something you count. Right, do you count the number of people in attendance, or do you measure them? Okay, and then that'll tell you how you're going to answer the question. Okay, so likewise, for number 3, the example here is that the distance a baseball travels after being hit. And you can clearly see that this is an interval on the number. Okay, so for example, the distance a baseball travels, right, can be a number between 0 and just over 500. Okay, so if we assume that this is the minimum distance a baseball travels and this is the maximum distance, right, the distance a baseball travels can be any number between the two endpoints, okay, making the interval. Alright, so that'll help you decide whether this is discrete or continuous. Okay, likewise with question 4, right, decide whether the random variable is discrete or continuous. And it simply says that X represents the number of motorcycle accidents in 1 year in California. Okay, so the keyword here is the number of, okay, Right, when you talk about the number of something, that means that you're actually counting it. Okay, something that you're counting. Right? The number of motorcycle accidents in 1 year in California might be a large number, might be a small number, but in any case, it's something that you can count. Okay, so based on that line of thinking, right, you would decide whether the random variable is discrete or continuous. Okay, so let's continue on to the next question. Okay, same thing, so I'm going to skip it. Okay, so the next question says determine whether the distribution is a discrete probability distribution, and here you have a table. Okay, so on one side of the table you have the values of x, and on the other side you have the corresponding probabilities. Okay, so to answer this question, you have to understand what a discrete probability distribution is. Okay, that's one of the key terms in your book. Okay, so this begins on page 191. Okay, and it says that each value of a discrete random variable could be assigned a probability. By listing each value of the random variable with its corresponding probability, you are forming a discrete probability distribution. So that's the key word there. Okay, then it gives you the definition. So a discrete probability distribution lists each possible value the random variable can assume, together with its probability. A discrete probability distribution must satisfy these conditions and the two conditions. Okay, so the first condition says that the probability of each value is between 0 and 1. Okay, and that's how you write this mathematically. So the probability of the value x is between 0 and 1 inclusive. Okay, so the probability could be 0, or it could be 1, or any number between 0 and 1. And then the condition number 2 says the sum of all the probabilities is 1. And this is how you state that mathematically. So if you add up all the probabilities in your table, right, they should all add up to 1. Okay, so if we go back and look at our table, right, we can see that each of these probabilities is a decimal. So 0.13, 0.27, 0.18, 0.27, and 0.13. So we can clearly see that these probabilities are each between 0 and 1. Okay, so when a decimal number begins with a 0, and then it's followed by a decimal point, okay, followed by other digits, okay, that decimal is between 0 and 1. Okay, so this table, okay, this probability distribution, if it is 1, right, satisfies the first condition given in the book, that each probability must be between 0 and 1. Okay, the probability of each value must be between 0 and 1. Okay, the next thing is that we have to add up the probabilities. Okay, so that's what we're going to do next. We're going to use a calculator to do that. Okay, so 0.13 plus 0.27 plus 0.18 plus 0.27 plus 0.13. Okay, we can see that it adds up to 0.98. So if we did this correctly, okay, you can verify that with the calculation here. Okay, right. If we did this correctly, right, we are getting the correct total, which in this case is 0.98. Okay, but remember in the book it says that the sum of the probabilities is 1. Okay, so assuming your table lists all the possible values of x, okay, the sum of those corresponding probabilities should be equal to 1. Okay, so because it fails to satisfy the second condition, okay, this table here is not a discrete probability distribution. Okay, and then you would select the appropriate answer choice. Okay, all right, so answer choice D would be the most appropriate because the total of the probabilities is not equal to 1, right? We got something slightly less than 1. Okay, which could mean that our table is not listing all the possible outcomes of the random variable x. Okay, so there could be some outcomes that are missing from our table. Okay, but in any case, the answer is no. Okay, so in the next question, you have to decide whether, or actually, what value to put the missing value in the table is to make it a discrete probability distribution. Okay, So we already know that the probabilities for each value, right, must be between 0 and 1. Okay, we can see that these probabilities, 0.27, 0.15, 0.29, are each between 0 and 1. Okay, so we have to use the fact that the sum of the probabilities, okay, is equal to 1. Okay, so we can actually write this out. So 0.27 okay, plus question mark plus 0.15 plus 0.29. Okay, assuming that those are all the outcomes possible for the random variable, right? If 3, 4, 5, and 6 are the only possible outcomes, right? The sum of all the probabilities, including the unknown probability, right, must add up to 1. Okay, so what we need to do then is figure out what is the sum of the probabilities that we do know. Okay, so 0.27 plus 0.15 plus 0.29. Okay, so those three probabilities add up to 0.71. Okay, so on the left-hand side we have question mark plus 0.71, okay, equal to 1, so the total should still be 1. Okay, so we're solving for the unknown probability. So to do that, we're going to subtract 0.71 from both sides. Okay, so the question mark is equal to 1 minus 0.71. Okay, you can do a quick mental calculation, or put that into your calculator, but in any case, so 1 minus 0.71. Okay, so 1 minus the total of the other probabilities will give you the unknown probability. Okay, so according to the calculator, it's 0.29, and the missing probability is 0.29. Okay, that's going to be our answer. So the probability of 4 is equal to 0.29. Okay, good. So let's move on to the next question. Okay, so in question 8, we have this table which says that the number of dogs per household in a small town. Okay, so the number of dogs is a whole number between 0 and 5. And then you have the corresponding probabilities. So in part A, it wants us to find the mean, variance, and standard deviation of this probability distribution. So if you look in the book, right, there are formulas for calculating the mean. Okay, likewise, right, we have formulas for the variance and then for the standard deviation. The good thing is that you don't have to use the formulas, because if you use the formulas, you have to calculate that all by hand, which can take a long time. Okay, so we're going to do this in StackCrunch instead. So to do it in StackCrunch, you want to open up the table in StackCrunch. Okay, or right, copy the table in StackCrunch. Okay, that's what we're going to do. We're going to go ahead and copy the table into StackCrunch. So select copy to clipboard. Hit Control-C or Command-C. Okay, and then go to an empty spreadsheet in StackCrunch. Okay, and then starting at the very top row, that we see var 3, var 4, and so on. Right, we're going to click in there and paste it. So Control-V or Command-V. Okay, so we have the x values and the corresponding probabilities. Okay, so next we're going to go to the Stat menu and then select Calculators. Okay, and we're going to go all the way down to Custom on the menu that pops up. Okay, so the values of the variable are in the X column. Okay, right, this column here. And then the weights, okay, so another word for weights are probabilities, are in the other column, P of X, and we're going to click Compute. Okay, and it'll give you the mean and standard deviation. Okay, and that's how you're going to answer question 8. So the mean is about 0.556, and we're going to round our answer to one decimal place, so it'll be rounded to 0.6.